The commercial purse seine fishing of skipjack tuna is an important activity in the capture fisheries sector, especially in tropical and subtropical waters. This industry not only provides a high-value food source but also contributes greatly to the economies of many countries. Here are some notable aspects of this industry. Katsuonis pelamis is a species of tuna, Scombridae, widely distributed throughout the world, mainly in warm seas. This species has high economic value, and is often processed into canned food, fresh tuna, frozen tuna, and other ready-to-eat products. This is one of the most exploited tuna species, accounting for a large proportion of the total global tuna catch. A purse seine is a large net that surrounds a school of fish. When the fish are surrounded, the net is pulled up to catch the entire school. This method is especially effective with species that live in large schools, such as skipjack tuna. Purse seining requires modern fishing vessels, equipped with advanced machinery and technology to locate and track fish schools, e.g. radar, sonar. Skipjack tuna is most exploited in the Pacific, Indian and Atlantic Oceans. In Vietnam, skipjack tuna is concentrated in the central and south-central coast. Overexploitation. The industry faces the risk of depleting skipjack tuna resources due to high demand and international competition. Environmental impacts. Purse seining sometimes catches non-target species, including rare species such as sea turtles, dolphins. International management. Many organizations, such as the Western and Central Pacific Fisheries Commission, WCPFC, have established regulations to manage and protect tuna resources sustainably. Technology application. Develop environmentally friendly fishing equipment and methods. Value addition. Increase processing and export of tuna products. Sustainable management. International cooperation to protect tuna resources. Enforce catch quotas and promote responsible fishing practices. The commercial skipjack tuna purse seine fishery is not only an important economic sector but also plays a role in ensuring global food security. However, strict management measures are needed to protect marine resources and the environment in the long term. Skipjack tuna fishing vessels equipped with aircraft are usually large-scale fishing vessels, operating mainly in the modern fishing industry. Accompanying aircraft are used to assist in detecting fish schools from above, helping to increase fishing efficiency. Here is how these vessels operate with the support of aircraft. Main vessel, tuna purse seine. This is a large vessel, equipped with a modern purse seine system and fish positioning and preservation equipment. Spotter aircraft, a small aircraft, usually designed to take off and land on deck or from shore, to detect schools of fish from the air. The aircraft flies at low altitudes to observe signs that there are schools of tuna, such as ripples or disturbances in the sea surface caused by the movement of fish. The presence of predatory seabirds, birds that often congregate where there are schools of fish. Floating objects, such as logs, natural rafts, that attract tuna. The aircraft is equipped with radar and cameras capable of taking pictures from a distance, helping to detect schools of fish faster and more accurately. When a school of fish is detected, the aircraft transmits information about the location, GPS coordinates, and direction of movement of the school of fish to the ship via a radio communication system. The pilot can guide the ship to the area where there are schools of fish faster, reducing search time and saving fuel. Once the ship is in the correct position, a purse seine will be dropped to surround the school of fish. The aircraft continues to monitor from above to ensure that the purse seine net covers the entire school of fish without missing any. Increased fishing efficiency. Aircraft help detect schools of fish faster, saving time and fuel for the vessel. High accuracy. Aerial observation provides a more comprehensive view of fishing areas. Ability to reach further areas. Aircraft can survey remote areas that vessels have not yet reached. High cost. Investing in and operating aircraft requires large costs, including maintenance, fuel and pilot training, technical requirements. Ships need to be specially designed to carry and operate aircraft, such as having a runway or launch pad. Environmental impact. Overfishing or the use of high-tech equipment can deplete fishery resources if not properly managed. This practice is common in industrial fishing fleets in the Pacific, Atlantic, and Indian Oceans, where tuna production is high. Countries such as Japan, South Korea, Spain, and the United States often use aircraft-equipped vessels in tuna fishing operations. Equipping tuna fishing vessels with aircraft is an advanced technological solution that helps optimize fishing efficiency. However, it also comes with challenges in terms of cost and sustainable management. Control measures and responsible fishing practices are needed to protect long-term fishery resources. Helicopter-assisted large-scale purse seine fishing for skipjack tuna is a modern, highly efficient method that is commonly used in industrial fishing fleets. Helicopters play an important role in detecting fish schools, navigating vessels, and optimizing the fishing process. Here is a detailed description of how it works. Large purse seine net. This is a long net, up to several hundred meters long, designed to encircle the entire school of fish. The net has a zipper system to close the bottom of the net like a bag, preventing fish from escaping. Tourism. This is an industrial fishing vessel, usually large in size and fully equipped with modern equipment such as radar, sonar, and fish preservation refrigeration systems. Helicopters are an important support tool in this method, with the following main tasks. Helicopters fly at low altitude and observe the sea surface to detect signs of schools of fish. Predatory seabirds. Seabirds often appear above schools of fish because they hunt small fish or squid, which are the prey of tuna. Shadows of fish. Helicopters can observe from above, identifying the shadows of schools of fish moving under the water surface. Water surface disturbance. When schools of fish swim or hunt, the water surface will have characteristic disturbances. Helicopters can search over a larger area than ships, saving time and fuel. When a school of fish is detected, the helicopter reports the exact coordinates, GPS, to the ship via the communication system. The helicopter can circle around the school of fish to observe their movement direction, and at the same time guide the ship to the ideal location to deploy the net. During the process of dropping and pulling the net, the helicopter observes from above to ensure that the seine net is deployed accurately, covering the entire school of fish. The helicopter determines the location of the school of fish and reports to the ship. The ship adjusts its direction to reach the ideal location. The net is dropped from the ship around the school of fish, forming a closed loop. The buoys on the net keep the net floating on the water surface, while the lead wire at the bottom helps form a closed pocket. Once the encirclement is complete, the towing system is activated to close the bottom of the net, preventing the fish from escaping. Collecting the net and bringing the fish onto the ship. The net is gradually collected, bringing the school of fish onto the ship. Fish are immediately placed in cold storage or frozen to maintain quality. Time savings. Detect schools of fish faster and reduce search time. Increased efficiency. Ensure accurate encirclement and capture of larger schools of fish. Wide operating range. Helicopters allow fleets to expand their fishing areas, especially in remote areas. High operating costs. The use of helicopters requires large costs, including maintenance and fuel. Environmental impacts. Large-scale fishing has the potential to impact marine ecosystems and reduce fish stocks if not managed sustainably. Bycatch of non-target species. Large purse seines can sometimes catch species such as sharks, sea turtles, or dolphins. This method is common among industrial tuna fishing fleets in the Pacific, Indian, and Atlantic Oceans, especially in countries such as Japan, Korea, Spain, and the United States. International organizations such as the Western and Central Pacific Fisheries Commission, WCPFC, often regulate this activity to ensure sustainable fishing. The method of catching skipjack tuna using large-sized purse seine nets with the support of helicopters is an important step forward in the modern fisheries industry, bringing high economic efficiency, However, strict regulations and responsible fishing practices are needed to protect fish resources and marine ecosystems. Technology supporting helicopter and large-sized purse seine fishing. In addition to helicopters and purse seine nets, industrial fleets use many modern technologies to increase efficiency and optimize the fishing process. Radar and sonar, used to detect schools of fish at different depths and determine the size of the school of fish. GPS system, helps to accurately locate the location of the school of fish and support ships to quickly approach the fishing area. Aerial observation cameras, mounted on helicopters to provide live images of the sea surface and the activities of the school of fish. Water temperature sensor, tuna often gathers in areas with suitable temperatures. This sensor helps detect potential areas. Deep freeze system, tuna is frozen on board to maintain its quality. Processing vessels, some vessels are equipped with tuna processing lines directly at sea, increasing the value of the product before bringing it to shore. The use of helicopters and large-sized purse seines, if not controlled, can lead to overfishing and negatively affect the marine environment. Therefore, international organizations have issued strict regulations. Some fishing areas limit the amount of tuna that can be caught each year to protect long-term resources. There are marine protected areas, MPAs, where fishing is not allowed to preserve biodiversity. Organizations such as the Pacific Fisheries Commission, WCPFC, or the Indian Ocean Tuna Management Organization, IOTC, regulate net sizes, gear, and fishing times to minimize impacts on non-target species. For the purse seine and helicopter fishing industry to develop sustainably, the following factors need to be focused on. Use of bycatch reduction devices, BRDs, to detect and remove non-target species in the net. Helicopter surveillance can help identify unsuitable fish stocks before netting. Countries need to coordinate to manage shared tuna resources in international waters and minimize fishing conflicts. The large-scale purse seine and helicopter fishing industry is moving towards sustainability and high technology. Key trends include application of artificial intelligence, AI. AI can analyze data from helicopters and ships to predict fish school locations and optimize fishing operations. Green transition, using biofuels or electric motors on ships and helicopters to reduce emissions. Real-time monitoring, remote sensing and IoT, Internet of Things, technology help manage and monitor fishing activities remotely. Ensuring compliance with international regulations. Large purse seine and helicopter fishing for skipjack tuna is one of the most modern and efficient methods in the seafood industry. However, sustainable management and minimizing environmental impacts must be prioritized to protect tuna resources and maintain the development of this industry in the long term. Although it is a modern method, large purse seine and helicopter fishing also has many potential environmental problems. These challenges need to be addressed to ensure sustainability and minimize negative impacts on marine ecosystems. During fishing, purse seine nets can catch non-target species such as sharks, rays, sea turtles, or dolphins. These species are often injured or killed by entanglement in the nets, affecting the balance of the ecosystem. Solution: use bycatch reduction devices, BRDs, and develop specially designed nets that allow non-target species to escape. Helicopters can assist in monitoring to avoid netting in areas with high non-target species. Fish aggregating devices, FADs, are devices that attract tuna, but they also attract many other species. Uncontrolled use of FADs can increase bycatch. FADs made of plastic or non-biodegradable materials can become marine litter, causing harm to the environment. Solution: switch to FADs made from environmentally friendly materials that are biodegradable or reusable. Limit the number of FADs used in each fishing area. Overfishing has led to a decline in tuna populations in many areas, especially in poorly managed waters. Although skipjack tuna reproduce quickly, if overfished, the population will not have enough time to recover. Implement strict catch quotas based on scientific data on population status. Establish no-take zones during the spawning season to protect young tuna. trawlers and helicopters consume large amounts of fossil fuels, leading to greenhouse gas emissions and pollution. Ship debris, such as oil slicks and plastics, can pollute the ocean. Using ships and helicopters powered by clean energy such as biofuels or electricity. Sustainable management of tuna fisheries is not only a matter of individual countries but also requires international cooperation. Some important organizations include monitoring and managing tuna fisheries in the Pacific, establishing catch quotas, regulating the use of FADs and protecting non-target species, managing tuna stocks in the Indian Ocean, including conservation and sustainable development measures, providing guidelines for sustainable fisheries, encouraging countries to adopt environmentally friendly technologies, certifying fleets to comply with sustainable standards in tuna fishing, thereby increasing the commercial value of the product. To face environmental and economic challenges, the purse seine and helicopter tuna fishing industry is moving towards sustainable development. Some trends include artificial intelligence, AI, is applied to analyze data from sonar, radar and helicopters, helping to predict fish school locations more accurately and reduce waste, using unmanned vessels to support fish school searches, reducing operating costs and greenhouse gas emissions, promoting the production of tuna products with sustainable certification, such as MSC, meeting the growing consumer demand for environmentally friendly products, increasing training for fishermen and fleets on environmental protection measures, reducing bycatch and complying with international regulations. The method of catching skipjack tuna using large-sized purse seine nets with helicopter support is a major technological step forward in the fisheries industry, bringing high economic efficiency, however, to ensure the sustainability of tuna resources and protect the marine environment. Close cooperation between countries, international organizations and fishing fleets is needed. Technological innovation and effective management will be key to the future of the industry. Purse and helicopter fishing not only bring economic benefits but also have important social and community impacts. Here are some aspects to consider. Contribution to GDP. The tuna fishery is a major source of foreign exchange for many coastal countries, especially in the Pacific, Indian and Atlantic Oceans. Employment, fishing fleets, processing plants, and related supply chains provide employment to millions of people globally. Exports. Skipjack tuna is one of the most sought-after seafood species in international markets, especially in countries such as Japan, the US, and the EU. Coastal communities. Industrial fishing creates employment opportunities, but can also cause conflicts with small-scale fishermen who rely on traditional fishing. Disparities in benefits. Due to the large investment requirements, ships, helicopters, purse seines, the industry is often controlled by large companies, while small fishermen find it difficult to compete. Food security. Tuna is a major food source in many areas, but overfishing can threaten the stability of the supply. Fishing rights. Some countries or regional organizations require licenses and quotas to control the resource. Disputes over fishing rights in international waters are complex. Shared fishing grounds. Industrial fishing fleets often operate in international waters or in the coastal waters of developing countries.